at the conference here, everyone's been talking about Docker, unikernels, doing really cool production stuff, Dockering all the things. I don't know about you, but sometimes you don't work at a place where you can Docker all the things. Or it's terrifying, you've got legacy apps, a whole bunch of stuff, but you still want to play with it, right? So we're going to talk about 3 things you can do, hopefully with no manager approval, and you can just have a good time. So first of all, we're going to just level set on Docker, because you don't need to know anything about Docker in order to enjoy this presentation. And then we're going to go over how we're using chat apps with Docker at Rackspace, how our developer experience team is putting together our websites and then deploying them using Docker. And then I have a really silly one about how to learn Docker on Docker. So this is my Docker in 60 seconds, just for anybody who doesn't know what it's all about or is just nodding their head but really going, I don't know what Docker is. It's container black magic voodoo as far as what you need to know in order to understand what we're chatting about here. And the way I like to think about it, I am not a Docker guru, but the way I think about it is I have an application. Let's say I have a Python app and I want to deploy it. Normally I'd go, okay, sure. I've got a server somewhere up in the cloud or under my desk, whatever, SSH into it, copy up all my files, apt-get install a couple different things, pip, whatever, and then a magic command to run it. All right, now I need to hand that off to test or to my poor little sysadmin, and they have to replicate whatever the heck I did in dev, which is not fun. With Docker, I can package up all of that into one nice binary that understands everything it needs to run. It has all of its dependencies, its config, etc., and it knows how to run itself. So here we have Docker run Nginx. So Nginx is an app hopefully we're all familiar with, and it's really just this simple to be able to go, I want to run Nginx, run this command, ta-da, and it's up and running. So that's your Docker in a minute, pretty much. This talk isn't explicitly about Karina, but a couple of us are using it, so I just wanted to level set what the heck that is. Karina is Rackspace's Docker as a service. Essentially, you can push a button on a website, and a minute later, you have a Docker swarm cluster set up for you, and then you can immediately just start doing Docker without a lot of hassle and not knowing how to secure things and knowing what run C is and AppArmor and all that. Somebody else's problem. So this is just a quick screenshot of it, and I have 2 clusters. One is McCluster, very important production system, obviously. And then separate from that, different credentials and everything is my little developer playground, where I can try things out and safely run Docker commands without borking anything in production. So without further ado, I'd like to hand this off to Nick, and he can tell you about chat apps. Yeah. It's free for now. It's in beta.
So that's actually a really good introduction to sort of talk about me. My name's Nick Silkey. I'm actually an operations engineer at Rackspace. So I work closely within a product team with developers and QE to build cloud product. I currently work on the cloud DNS team, and I do a lot of operations and release engineering stuff there. I've worked on a few different teams there, but that's sort of the perspective for sort of the rest of this talk here, where sort of I come from. One of the things that's been really helpful within my product team here within Rackspace is using something that gets referred to in the industry as chat ops. If I can just sort of poll the audience here, who's actually heard of the term chat ops? About half of you. How many of you actually use it? About 2, 5, 6 of you? Okay, that's cool. So essentially, the big key takeaway here is that in order for me to do my job, I sort of do lots of things all the time, but maybe they're not as visible as they could be to other people. Essentially, Jesse Newland from GitHub defines chat ops as putting tools in the middle of the conversation. We're sort of talking and conversing all day, every day within sort of a multi-user chat. This is me taking those functions that I do of what it means to build something, release something, acknowledge a monitor, perform some sort of administrative function. I'm going to do it within chat so that other people can sort of see what it is that I'm doing there. So one of the things that we've done with regards to different ways to sort of live outside the container is we take advantage of a tool called Hugh Bot. It is another sort of code project that came out of the GitHub operations team there, and essentially it is a Node.js based application that can talk to a persistent data store like Redis, or if you want some SQL. And it allows me to sort of have all those functions that I intend to do in chat as an operator of a product team within chat. So it's actually been really, really cool and useful. One of the ways that we've sort of improved our situation as a product team who maintains, an API for a product in Rackspace Public Cloud that faces customers is we've gotten really, really good at incident response with regards to, utilizing ChatOps and utilizing Docker-based ChatOps in order for us to be really, really good at responding to incidents. So if you think about what it means to manage an incident, it's inherently a very collaborative process, right? Engineers are talking to stakeholders, talking to leadership, talking to incident managers. You need to be able to sort of do that work inherently out in the open. Utilizing ChatOps as a way to deal with, sort of restoring service or removing impact to service in the public, in the open, using these tools has been wonderful. The other thing that we sort of do here too is that my team uses Chef, which is a configuration management tool, a declarative configuration management tool that's really, really popular. It's comparable to sort of Puppet or maybe Ansible a little bit. We sort of use it, and it's a tool that sort of works really good under the scenes or behind the covers. And sometimes you as an operator might use Chef or call Chef to go do a thing, but there's not necessarily that visibility to the rest of your team of like, oh, hey, Tom, Dick, or Harry went and converged a fleet of infrastructure and did it unbeknownst to you. So if you don't have visibility to that, that can be kind of painful. So one of the things that ChatOps enables our team to do is to take those Chef functions and to actually run them out in the open like I would with a normal sort of ChatOps type tool. So I can actually take a look at the state of my fleet. I can conduct searches within Chef Search. I can also take a look at all the different configuration objects that are what make up my fleet in terms of my environments, my roles, all that stuff. I can sort of take a look at that stuff. That's been really, really wonderful, right, for the team to understand who's sort of doing what with a tool. Another thing that we've done too also is that we utilize continuous integration tool, Jenkins, in order to run all manner of things for us, but basically establish a pipeline for us to sort of run a build for us to ship fixes or features up and out to production. Rather than have a person clicking a button in Jenkins to say build the thing, or maybe possibly calling an API to do it, we actually do it sort of out in the open with plugins to Hugh Bot along with Jenkins to allow us to say, give me a build, please. It does support parameterized builds, so if I have something that's reasonably dynamic, like I might want to take a particular topic branch and deploy it out to an environment and sort of run some sort of acceptance test on it, or I want to dial some worker count up, as long as my jobs are parameterized, I can feed that stuff through chat, through Hugh Bot, through Docker into Jenkins. It also supports identities, so you get an understanding of who did what when. In terms of a person, there's an idea. Hugh Bot understands, or ChatOps can understand who is who in chat, so that when a person says "build me a thing," you have sort of an audit trail of who asked to build the thing. The other thing that's also really helpful here too is taking a look at sort of the state of our runs. I don't really ever have to go to the Jenkins UI anymore to know when's the last time a build was run or what's the state. Are they sort of red or green? I can take a look at that stuff through chat. It's really, really cool. There's a bunch of other sort of, it might be minutia, but it actually really, really has been really helpful to help sort of push a team that was reasonably high functioning to sort of make them even closer and more of a tighter unit who's able to work really effectively and make them sort of even more collaborative. So there's lots of seemingly trivial little things in terms of utilizing funny stuff, or the pound M thing is something we do very often where we sort of congratulate a person like, hey, you're doing a great job, whatever this is. We use that pretty often as a way to sort of cheerlead each other as we do great things, and then we also take advantage of sort of karma for rewarding people for doing great stuff. So let's take a step back and what does that have to do with containers, right? So one of the things that our product team came to the story here is that we at the Tokyo Summit when OpenStack Arena was announced, or when Rackspace Arena was announced, one of our developers took a look at it and was like, wow, this looks like a really great way for me to take the playing that I'm doing with Docker Compose and throw it onto a Swarm cluster in a reasonably turnkey way. So within less than an hour, our semi-complicated OpenStack-backed product, we run sort of OpenStack Designate, which is sort of DNS, the control plane for DNS for OpenStack clouds. He was able to sort of roll that into the necessary YAML that's required for you to fire up our stack within Docker Compose and actually deploy it on Carino. So that was really, really exciting, right? That he was able to deliver that really fast for us. So we had been utilizing Hugh Bot and sort of ChatOps on sort of a totally different platform. And we said, wow, we're really sort of happy with the way things are going with us using Carino for us to run these Docker Compose builds. Maybe we should bring this stuff home to the mountaintop and actually run it within Carino. Let's try that. One of the things that was really, really cool here is that in under an hour, like we were able to start the process of spiking out what it means to conduct the migration and actually execute and get it done, which I think is really, really powerful and compelling, that I was able to pick up a workload that was running here, move it over here, and voila, it works, which includes me moving a data store from one place to another. Another thing that I'll sort of call out here too is that living in sort of a Heroku world where you have a non-very configurable sort of proc file, or you just sort of declare the stack it is that you intend to run within Heroku. The cool thing about Karina, or the cool thing about composed Docker-based solutions, is that I can take my Docker file and customize it in a reasonable amount in order for it to do sort of extra things here, right? So it might be kind of hard for me to shove private keys within Chef or Ansible within my ChatOps bot in order for it to interface with sort of authorizations. With Docker, it's more or less more composable, no pun intended, for me to sort of bring that stuff in the form of a Docker file into what it is that I intend to run. So yeah. So with Designate Karina, one of the things that we did to sort of make it really, really easy for new people on our team to sort of onboard this stuff is that really the only thing they really have to do is to clone the repository where we store all the Docker Compose stuff that comprises Designate Karina, and run 3 commands more or less to sort of make it happen. So they can call and make Bootstrap, which will satisfy all the necessary components for them to lay down the Karina runtime and some other sort of bits there. They'll call a cluster create, which will do exactly what Carolyn was talking about, where it'll sort of pop a Docker Swarm cluster for my tenant in Karina and make it sort of ready for me. And then I'll call a make all, which will say, go ahead and rampage through everything I've declared in Compose and go build me a stack in that single tenant Swarm cluster that you asked me to do. If I sort of take a look here, in Designate Karina, I've sort of pre-staged, there's like a sort of a brand new cluster here sitting in an active state. What I can actually do is just call the make all, and it will actually rampage through doing all that's necessary to build all of the components of the stack, like central API, pool manager. This includes data stores and message queues and all that stuff. I declare that in some YAML that I feed to Compose, but I wrap it in this make file. It makes it really, really easy for my team to start going on stuff. So moving on from that takes a few minutes to build, but yeah, it's a really great thing to do. The next thing we sort of did was, with regards to bringing the bot home, was that we sort of took the same approach here. I should be able to hydrate everything that's necessary for me to instrument the runtime. I should be able to pop the cluster, manage the lifecycle of the cluster. And then some things that I'm going to sort of be expected to do over time is I might call a build. I might want to run a Docker build. I won't want to start it. I might want to check on the state of it, like, hey, is it running? What's going on here? I might want to take a look at the logs. If I do push an update to it, I might actually want to go ahead and roll it, or just sort of, build, stop, start, that sort of order stuff right there. I might also want to bring some of those extensible things that I talked about with what makes Hugh Bot great are these packages of people with written coffee scripts that allow you to sort of bring prior art that they've already contributed upstream into the open, bring that sort of stuff down from NPM and make it part of sort of my bot's runtime here. So I can actually say, go ahead and find me, if I really care about shoving pugs into chat, go ahead and see if there's a package out there for that. Oh, if there is, go ahead and add it to my manifest. Then another thing we sort of do here too is like, is there a bunch of stuff out there? Have we fallen behind in versions here that we should sort of update for here? So let's go ahead and rampage through everything. So if I take a look here, if I just sort of check back in, I'm done, right? Like I've built all of those containers. It's really, 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 really exciting stuff. So I sort of did a similar thing here within the bot. I've just sort of said like, hey, what's the state of my Karina cluster, right? But I might actually run a build, which just says, go ahead and rampage through and build me a container here. I'm running a little low on time, so I'll sort of just shunt the demo that I intended to do here. Was basically run me a build, show you in chat sort of where it is, and also exercise the process of what it means for me to extend it and have lifecycle management of it, where I can basically say, go ahead and call a package search, find what I want, call a package add, it adds it to the manifest, and then I just call a make roll, right? And it's going to go ahead and rebuild it and respin that for me with that package, and now I have the extensibility for me there running live in Karina. So really, really cool stuff. So that's about all I got. So I'm going to hand this over to Ash, and he's going to talk to you about documentation previews within the container.
Hi, everyone. I'm Ash Wilson, and I help run documentation infrastructure at Rackspace. If you've ever hit a site on any of these 3 domains, then your request has been, in the past maybe a year, then your request has been served by the software I'm going to be talking about today. About a year and a half ago, before we started, historically, the content that was maintained on here, so there's about 30 GitHub repositories contributed to by a few dozens of technical writers and other rackers. And everything was managed differently by different people and different teams. There were different processes for how you get updates in. It usually involved finding the right person to email or something like that and doing some kind of politicking and stuff like that and back and forth and so maybe your change would go out today, maybe your change would go out next week. You never really knew what somebody else's schedule was, and it was sort of chaotic and not very nice for the people who do this every day, all day, and even less nice for people who wanted to contribute and who from the community who actually use this documentation. So we were approached to help streamline this and modernize it and make it more continuous and approachable and everything like that. And when we were first sitting down to design this, the big thing that we really did not want to do was to come in and say, well, we have a mandate to make you all we have a mandate to take over how documentation is written here at Rackspace. So you're going to have to use our tools. You're going to have to use our WYSIWYG editor and learn our markup for whatever stack that we've chosen for you, and just convert everything that you already have, these giant repos full of stuff, into whatever we've chosen. Because then what's going to happen is that, number one, people are going to be sort of irritated with you and not be approaching it as something that's helpful. And number two, then probably won't even get it done before we move on to something other than this. So you'll just be perpetually moving from state A to state B. So instead, what we decided to do was meet people halfway and kind of adapt to things that they were already doing as much as we could, which we did with a project which I called Deconst. I describe this to people as an inverted CMS. If you run something like WordPress or Drupal or any other CMS like that, they tend to be very opinionated up the stack. So that's where they have an editor that they want you to use. They own the database schema, all of that. What we wanted to do was to unify infrastructure and metrics and logging and search and all of those sorts of things by bringing the content together, but to keep separate the GitHub repositories where that work is happening, so that the teams that are doing that can use the work, whatever flows they want, and not have to abide by other people's rules. From the very beginning, there was a big gap in functionality, though, which is that whenever you're just writing something with Sphinx locally, you can type make HTML, and you get a HTML page that you can look at to see what it's going to do. If you have, or Jekyll, if you have Jekyll build, Jekyll serve, you can kind of get this nice local preview so you can see what you're working on. It's really important, especially for things like if you have lots of text that's wrapping around images, for example. Getting that just right can be kind of a pain. Another thing is that, so you can no longer do that with Deconst because we hook into that build pipeline and we separate the templates that decorate the content from the content repositories where the work is happening. So there's this disconnect. And you can sort of tell from the markup and everything like that, but it was very awkward. So we tried a few things. We had a staging server for a while. That's painful because we have 30, 35 GitHub repositories of work happening, and only one person can really be staging changes at a time. And so you kind of linearize your process. Not only that, but if you try to separate stuff with Git branches, your Git workflow becomes really, really painful. So we wanted to avoid that. We played with Vagrant a little bit for a while. We had a Vagrant environment that we had baked for some of this early work. And I'm not actually sure it worked for anyone other than my laptop. So what we settled on was Preview Link. So we have a staging environment as part of every Deconst cluster. And if you submit a pull request to any repository on GitHub which is publishing content to a Deconst cluster, a minute or so later, you'll get a bot posting a link on your pull request, which you can click through. And this will take you to a personalized build environment on our staging server that is unique to your commit, which has the entire site has your changes overlaid in front of the entire rest of the site. So the documents that you've changed will be your versions, and everything else is exactly as it is on production, which is really valuable for doing things like testing changes to navigation and making sure that you don't break. You can get consistency across different repositories in different places. How does the content get there? Well, we use continuous integration solution hosted in a Docker container. And we use a CI product called Strider, which is open source. We used Travis for a while because the less of my infrastructure that I have to go in and be responsible for, the happier I am. But we ran into problems whenever we started to onboard repositories where the source code for that product is in the same repo as the documentation, because build environments collide badly. And so there were there was this awkward period of time where we had certain repositories where people were hand jamming changes in to keep things up to date. So we've self-hosted with Strider. And Strider is nice because it's kind of extensible. I was able to write a few custom build plugins for Strider to be able to manage our build processes. And our build processes take the form of a sequence of containers. The first of these is called a preparer. This is where we actually take Jekyll and Sphinx, real Jekyll and Sphinx code bases, and do sort of evil things to their source to like monkey patch stuff into Jekyll so that they can output JSON documents in a format that dconst expects instead of their native format. We do try to keep things as consistent as possible with the real engine, because there's these ecosystems of plugins and extensions and customizations that you can do with Sphinx and Jekyll and other engines like this, which is the reason why you're using them in the first place. So we wanted to keep everything as consistent as we could with the native environment. There are exceptions to that, especially for things like assets, because we have to do our own asset handling and things like that, but we've gotten pretty close. And so the preparer runs in a container and writes a bunch of JSON files to a workspace. It's very important that this is running in its own Docker container too, because if you've ever tried to set up Jekyll and you're not a Rubyist, it can be kind of painful. It has a lot of dependence, especially Jekyll 2. They've gotten better in Jekyll 3. But you used to need to install a certain version of Node, a certain version range of Node, a certain version range of Ruby. It builds a bunch of native extensions, and so you need builder tools on it and things like that. And so by packaging the preparers as Docker containers, we can do all of that ahead of time, kind of ship it as a box, and then be confident that it will run consistently on our build server without falling apart. Especially if we add another preparer, we don't have to worry about balancing, having sysadmin sort of hand tweaking and balancing packages and bundler and pip and all of that stuff to keep things consistent across all of the preparers. So that's a big win for us. The second container is common to all of the sort of shared functionality among all the different kinds of content repositories we support, which is the submitter. What the submitter does is traverse the output directories from the preparers, look for all those JSON documents and assets and so on, fingerprint them, query an API to see what's changed, pack the stuff that's new into a tarball, and submit it. So doing differential builds is really important because your common case for this is not an entire submission, but it's somebody came and wants to fix a typo, which is a single page. And you really don't want to, if you don't have a build server which is gigantic, you really don't want to, for example, be submitting 93 megabytes of assets on every single commit, to choose a totally arbitrary and not real at all example. So implementing that actually changed our turnaround time from like 20 minutes to 30 seconds to a minute on some of these, which is cool. So that's the overview of what's going on. I've taken the liberty of that's big, but a little too big. Taken the liberty of pre-staging pull requests to one of our sites here. I was really waiting for so I just went in with the GitHub web editor, which you can do, and just changed the tagline in the markup on our front page here for getcarina.com. If we go back to the conversation, and if I can click appropriately, there we go. Our bot account posted a link here, so we click that, and boom. There we go. So notice how up here in the URL, we have our own environment. If someone else, if I pushed another commit, I get a new environment and would have those changes and so on. So with that, dconst hosts its own documentation on a dconst instance at dconst.horse, because I will never not find .horse domains hilarious. And all the source code is at the dconst org on GitHub. So thanks. And now I'm going to turn it over to Carolyn to...
Now for the totally nonsensical part of our presentation. So I've been teaching Docker now for a couple months, and I always run into this catch-22 when you're trying to explain to someone why they should care about Docker and go through the trouble of learning it, which is until you've done Docker, you're kind of scratching your head over when would you use it, why, how, is it a fad, what's going on here. So I wanted to take a copy, basically what say like tryjulia.com or codeschool.com has done, where you can learn something in the web browser without having to install anything on your machine. And I said, dang, Docker needs something like that. I want to learn Docker without, the new Docker for Mac and Windows is really awesome, but at the time it was Docker Toolbox and it was really tough, especially if you're on Windows. And I wanted something that in 2 minutes you could run a Docker container without having to know anything about Docker. So I'm going to jump right to the fun part, which is the website. So this is ginormous. Awesome. So this is howtowhale.com. It's just a prototype. I'm not a designer in any way, shape, or form. But basically what it lets you do is log in with your Karina credentials, which is free. So you were asking about that. So Karina is free during beta, and I think there'll be a free tier forever so that devs can do fun things with Docker. So you click the Try Docker button, and it brings you to a page where you can log in with your Karina credentials. It uses OAuth, so you just pick the, dude, your mouse is weird. All right.
You gonna click it?
No, it's doing something. It's totally doing something. Awesome. Okay.
Right.
So this started up a server for me on my own Karina account, not on How to Whale, on my account. And from there, I can open up my server and start learning Docker. This is taking advantage of something called Jupyter, which I'll get into in just a minute. But what it does is it starts you out with a notebook pre-filled in with a whole bunch of code that you can just say, I'm learning Docker, and start pressing the next button and kind of seeing what Docker looks like and running live Docker commands. So I'm going to open up this Try Docker notebook very slowly. Awesome. Whew. Okay. So the way these notebooks work is there's little code cells where you can type in like pre-done code, and you press the magical run button. And there we go. I just ran a Docker container. I don't know anything about Docker. I have nothing. This isn't my laptop. You have to install anything. And I don't know if you can see right here. Hello. Oh, man. Hello from Docker. So one command, no setup, no config. Bam, I'm doing the Docker. So I'm feeling pretty good about this already. That's kind of contrived, though, right? So what I'd like to do is be cool. I want to run a website. So I found this really awesome Docker image called Racker Labs Whoa. And it'll run a website and publish it on port 80. So let's give this a shot and see what happens. All right, so very friendly container ID just got output there. But you don't have to take my word for it. This is real. So we're going to run Docker PS, which is going to list all of my running containers in my Docker cluster. And we can see that there's whoa, it's running. It's been running for about 13 seconds. Well, that's cool. But actually, you said this is a website. I want to see the website. So here I'm going to use the Docker port command and ask it, hey, where is this whoa container running? I'd like to take a look at it. So I'm going to run that, and it gives me this live public web address. I told you, it's an amazing website. You should all try it. And then once I'm done, I'm going to be a good camper here, clean up after myself, and I've removed my container. So that's How to Whale. It shows you basically a little bit about Docker, and hopefully after you go through it, you can go, hey, this is actually going through this is worth installing on my machine, going through the trouble, maybe, God forbid, reading the Docker book. That would be super useful too. So what's happening under the hood? So the How to Whale is cool, but I didn't come here to tell you about, hey, I'm so awesome. That's really not the point. What I wanted to show you is that I didn't actually have to write a ton of code to make this work. What it did is it took Karina and totally abused it and said, I want free compute, essentially, which they're happily giving away. And then I took something called Project Jupyter and combined them together so that I could run code. And Project Jupyter is made for data science, and this is totally not data science. So again, we're off in La La Land. So real quick, what Project Jupyter is it's this website that you can spin up. You can run locally, or if you use Jupyter Hub, you can run it on a web and have people log in. and have lots of people in there. And so this one, I have a Python notebook. So I was able to run Hello World. It's my favorite example. And as you can see, it prints out at the bottom there, Hello World. And again, nothing was installed, and you can just kind of use it. And you can run a whole bunch of different languages. So for example, Julia, R, Python, .NET, lots of different things. So that was really cool and all, but what was really happening under the hood, okay? Because we want to build one of these ourselves. So what really happened was I had my web browser, and I typed in, Docker run Hello World. What that did is it directed my request to Jupyter Hub. Jupyter Hub looked at the URL and said, oh, okay, I know, you're Sally. All right, I'm going to send this over to Sally's Jupyter server. And if you take a look at this, Sally is actually running her Jupyter server on her own Carina cluster. So I'm not paying for Sally trying out these tutorials. Sally has it off on Carina, and all I'm doing is maintaining this really simple little proxy, essentially. So Jupyter gets that command, Docker run hello world, and goes, sure, I've been pre-configured to know how to talk to basically the Docker Swarm cluster that I'm sitting on, and it spins up the hello world container, and then the output trickles back to the web browser. So that's a lot is going on under the hood, but what's interesting about it, the reason why I'm boring you to tears with what is going on, is that I can scale my website out. I could become wildly popular thanks to OSCON. And if I get 500 people to try it out, I'm not paying for 500 people to try out and try Docker. Each user is bringing their own compute and running everything there. But as far as the user's concerned, it was one button click that said, sign me in with Carina. I'm cool with this. And then after that, it was completely transparent to them what was going on. So that was how I built How to Whale, but the two components that I'm using, the bring your own compute with Carina, and then just completely abusing Jupyter to run whatever you want, is something that you could do to build other things as well. So I use it to learn the Docker CLI, but you could use it to explore a REST API, perhaps. Or what I'd really like to do is make it so that, say you're teaching a workshop, you're going to a conference, and you've got 100 people who all need to set up whatever on their laptop, and then have them all Git clone, and half people don't have Git on their machine, and someone has Python 2.7, and it's kind of a mess. Imagine instead you want to teach a workshop, you can just go, okay, I'm going to spin up Jupyter Hub, I'm going to put on some of those notebooks. So my notebook here was Try Docker. You could make a notebook called Try Kubernetes, or I don't know, Try Julia, it doesn't matter. And then just have everyone log in, and then immediately start doing your workshop, and you can kind of remove that stress of, how do I get all this up and running, and what happens if everything stops working? So I hope you give it a try. And by it, I mean Docker. Just do something with it, even if it is just as silly as like a How to Whale, or running chat ops, or running your entire website off of Docker, which is actually ridiculously cool. But it doesn't have to be your flagship app. It doesn't have to be something that you convince management and CTOs to do. It could be something that you just decide to do rogue on the side, and eventually maybe that'll trickle into the rest of your company's infrastructure. So thank you very much.